if I'm identifying these as true or false, if I have 8 to the 3 divided by 8 to the negative 1, 3 minus negative 1 is the same as 3 plus 1, which would be 4, and this is true. When I get to example B, 8 to the power of 3 over 4 to the negative 1 is equal to 2 to the power of 4. You can try it in your calculator. This is false. I can't combine them like this because they don't have the same base. If I have a to the negative 3 is the same as 1 over a to the 3, all we did was make this negative exponent positive by moving it to the denominator, and this is true. And if I have 9a to the negative 3, it's equal to 1 over 9a to the power of 3. This one is false because that power of negative 3 only applies to a. It does not apply to the 9 because it's not in brackets. The 9 is a coefficient. It's not part of that base. So if I need to simplify and answer with positive exponents, I'm doing the same process that I did with example 1. It's just in this case I can't solve them because they have variables. So negative 4 and negative 3 combine to make a to the negative 7, which is the same as 1 over a to the power of 7. If I have 6x to the power of 2 divided by 2x to the power of 7, then I'm going to say that this is the same as 6x to the 2 over 2x to the 7. I'm going to deal with my coefficient and my x's separately. And 6 divided by 2 gives me 3. And 2 minus 7 gives me x to the negative 5. And remember that this negative 5 only applies to the x's. So it's the same as 3 over x to the 5. Don't bring the 3 down as well. For example C, if I have y to the 6 over 2 y to the negative 5, 6 minus negative 5 is the same as 6 plus 5, and I have y to the 11 over 2. Now, for this one, it's interesting because the negative applies to everything inside of the exponent, which means that, everything inside the brackets, not the exponent, which means that I could get rid of this negative by saying that's the same as 1 over bracket negative 2x to the power of positive 3. And remember that the power of 3 applies to the negative, to the 2, and to the x. So to the power of 3, it's still going to be negative. The 2 to the power of 3 is going to give me 8, and I have x to the power of 3. Example E is interesting because here I have the coefficients that can be divided. So I have 8 divided by 4 is going to give me 2. But then the a and the b aren't the same. All I can do is make those positive. Well, how do I make the a positive? By moving it down to the denominator. How do I make the b positive? By moving it up to the numerator. So if that's true, then suddenly b is going to become in the numerator, and the a is going to be in the denominator, and it's just the same as 2b to the power of 3 over a to the power of 5. For example F, I'm going to make this whole power positive by moving all of this down to the denominator. So I can say that I have, if I've moved everything out of the numerator, 1 over 5 q4 and bracket 5p squared. This is going to be the same as 1 over 5q4, and 5 squared is 25, and I have a p squared, and then I still need to remember to multiply 1 over 125 p squared q to the 4. I'm really just doing the same process for all of these. So here, if I am taking all of this and I'm dividing it by all of this, I'm probably going to simplify the fraction on the right to begin with. I'm going to say that this is still 5x3 y to the negative 8 z to the negative 2 divided by, and when I simplify this, if I have 15 over the nothing, it's still 15. X to the 8 divided by x to the 5 is going to leave me with x to the 3. Y to the 3 over y to the negative 3, 3 minus negative 3 is y to the 6. And negative 1 minus 2 for the z's is going to be z to the negative 3. Now that I've simplified this, I can say that if I stack it on top of each other, I have 5x3 y to the negative 8 z to the negative 2, all divided by 15 x3 y6 z to the negative 3. The 5 over 15 is the same as 1 over 3. The x's cancel each other out. If I have negative 8 minus 6, then that is the same as negative 14 or positive 14y's in the denominator. And if I have negative 2 minus negative 3, that's the same as positive 1z in the numerator. And this coefficient of 1 in the numerator is redundant. And there's my answer. We've already seen examples like this. When it says explain why 2p to the negative 3 is not the same as 1 over 2p to the power of 3, it's because 2 is a coefficient. And the negative exponent does not apply to it. If I'm simplifying a fractional base with a negative exponent, anytime I have a rational base like this, remember that the exponent outside the brackets applies to the numerator and the denominator. So if I said that I took 1 and I was dividing it by 2 over 3 to the power of positive 4, or when I actually divide this out and I get to the power of 4 gives me 16, and 3 to the power of 4 gives me 81. When I divide by a fraction, it's the same as multiplying by the reciprocal. If I'm evaluating 3 over 2 to the power of 4, then I would take 3 to the power of 4 is 81, and 2 to the power of 4 is 16. So, is it true or false that 2 over 3 to the power of negative 4 is the same as 3 over 2 to the power of 4? We just proved that it was. So if I want a quicker way of doing it, if I know that the negative exponent moves from the numerator to the denominator, or the denominator to the numerator, then what's a quick method for evaluating? If I have an exponent like this applied to a fraction, then I take the reciprocal and apply the positive exponent. In this case, if it was 5 over 2 to the power of negative 3, it's going to be 2 over 5 to the power of positive 3. Or if I have a over b to the power of negative n, then it's the same as b over a to the power of positive n. All right, go ahead, try some practice.